honestly I think most of you guys can do completely on your own. I want you to feel free to just jump into this, see what you can do. I'm going to have some conversation with the friends at North Central and East End, and who knows who else is watching the video. We'll just go from there. But all the friends in the room are working. Alright, Mrs. Pandia and the Gardening Club are planting a new garden for the Southwest Campus. They have a total of 32 yards of fencing available to place around the garden. Okay. They've decided to place the garden right next to a building in such a way that the building forms one side of the garden and no fencing is needed there. Assuming they use all of the fencing available, what are the dimensions of the garden which will generate the garden with the largest area? Show the work which supports your answer. This is the kind of problem that we're going to be playing around with. Things we know for sure. We know that we've got 32 yards of fencing. And I'm only going to fence in the garden. So I need fencing along this side, I need fencing along this side, and I need fencing along this side. Now the thing that we need to be careful about is that we don't start making assumptions that have no business being made. For example, is there anything that says the length of this side and the length of this side have to be the same? No, so don't make that assumption. Is there anything that says the length of this side over here and the length of this side over here have to be the same? There is actually something that says the length of this side and the length of this side have to be the same. And the word is, it's a rectangle. It's a rectangle. The last time I checked, all my rectangles, opposite sides are congruent and parallel, so those two have to be the same, but this one does not have to match. So I've got 32 yards of fencing. The other thing to be super careful about in a problem like this, where are you putting the fencing?
On three sides.
On 3 of the 4 sides, not all 4 sides. So if I look at my fencing equation, I know that for fencing I have 32 yards and I need an equation. Well, depending on the variables you want to use, I might call this length and I might call this width. You might call it X, you might call it Y, it doesn't really matter to me what you choose to do. But be careful with the 32. The 32 has to be equal to your length plus 2 widths. Everybody okay? Alright, let's see what we can do with this. Alright, assuming they use all the fencing available, good, I'm not going to have any fencing left over. What are the dimensions of the garden which generate the garden with the largest area? Well, the area of a rectangle is length times width. As soon as I see this largest, I'm thinking, oh, this is an absolute max kind of question. So if I'm going to do an absolute max, we're going to take a derivative. We're going to set it equal to 0. We're going to do all the things. Okay. Polymon, what's the problem with taking the derivative here? You've got 2 different variables, so what's your strategy?
Solve for one.
Solve for one, but where? Because this equation, technically you have 3 variables. You have the area that you're trying to find, you've got the length and the width. It's this other equation up here that we're actually interested in. And the fancy word that I used for this the other day, anybody remember? 32 equals L plus 2W. Lewis, what's it called? This is actually not your optimization. This isn't what you're trying to make big. It's the area that you're trying to make big. So it's this area equals length times width. This is your optimization equation. The fencing equation is what we call the constraint. It's the thing that says I don't get to use any length and any width that I want to. I have constraints on the problem. Length plus 2 widths has to be equal to 32. It is, generally speaking, the constraint equation that you need to go back and solve so that you can use in the area equation. Things are about to get way fast with the calculus here. So 32 equals L plus 2W. You have the freedom to solve for any variable that you want to. I would say let's solve for L. So L is 32 minus 2W. you've got that, so that means that my area equation now is going to be 32 minus 2w times w. That's my optimization equation in one variable. This is a good sign. This is what I want to go and I want to take my derivative of. My derivative options here include, what's an option? Product rule. Anybody have another option? How about algebra first, then some calculus? I don't really care which way you go. I think one way is probably easier than the other, and a problem like this, I'm going to avoid product rule. Why bother with product rule? Okay, so I'm going to get 32w minus 2w squared. A prime is 32 minus 4w. I'm going to set that equal to 0. I want to see that I'm setting this equal to 0, and that means that my width has to be 8. Everybody's okay? Now, here's the mistake. Lots and lots and lots of folks are going to stop here and say, oh, this is the optimal solution. I've proven it. No. What you found is a candidate. You found where the derivative is equal to 0. You don't stop here. You now have some options to consider. Option number 1, maybe you want to do like a number line test and have some sort of an argument about that. You can do the number line test. Now, somebody else might say, wait, you know, when we first started doing this, we would take that internal candidate and we would evaluate the original area function. And we also did something else. It was never just the candidate. You also went for endpoints. Anybody know the endpoints? Celeste sees them. Are there even endpoints for this problem? Celeste, what are my endpoints going to be?
0 and 16.
0 and 16. If we're talking about W, right? So you're saying that W has to be between 0 and 16. Can you convince me?
Well, because you can have 0 width.
You could have a width of 0. Theoretically, what happens if you have a width of 0? You have no garden, right? You have no garden. You just say, hey, I fenced in an area by running 32 yards of fencing along the building. That's an option. The other extreme, you use 16 yards here, 16 yards here, and you have no length. But is everyone? These are like the natural boundaries. Bigger than 16, not possible. Less than 0 makes no sense. Okay, so good news. I have a continuous function. I have a closed interval. Does there have to be an absolute max?
Yes.
And there has to be an absolute min. Thank you, extreme value theorem. Okay, God rest their souls. All right, so your choices now are, I'd say option 1, find the area at 8, find the area at 0, find the area at 16, right? We're just evaluate your candidate, evaluate your endpoints. Option 2, not a bad option. I really like option 2. With option 2, I'm going to make an argument that goes something like this. If A prime, if I graph A prime on a number line, here's 8, here's 0, here's 16. What happens with A prime before I get to 8? I pick a number like, I don't know, 4 or 5, whatever. Plug it in, 32 minus 4 times 5, that's a positive. Between 8 and 16, I pick something like 9. Plug it in, 32 minus, I don't know, 4 times 9, I'm going to get a negative. What do we know is happening at W equals 8?
Maximum.
Let's be specific though. What do we know based on the number line test? We have a relative max. So you can say A has a relative max at W equals 8 because A prime makes a change from positive to negative. That's good, that's strong. However, it doesn't answer the question. You have not proven what we're actually out here to prove. Celeste, you're frozen for a little bit. Polymon, what is it that we actually want to prove?
The absolute.
That this actually causes an absolute maximum. How do we know for sure that it must be an absolute maximum? This is the thing. This is the argument that you need to be able to land the plane on. I'm convinced, relative max, and I hope everybody else is. Why does this have to be an absolute max, Lewis?
This is the only place where A W would equal 0.
That's actually not it. It's not that it's the only place that W equals 0. It's the only place that
There's the only change in that.
it's the only change in the derivative on this interval, and if this is the only change in the derivative, then think about what happens with the original function. The original function increases and decreases, and it's not allowed to do anything else. So I'd say something like, because this is the only change in sign, change in sign for a prime, this implies an absolute max. How's everybody doing with this idea? The thing you want to avoid is stopping here and saying, I'm done, I have a relative max. Now let me tell you, option 1 would have been so much easier, so much kinder, because in option 1 you have your candidate, and you have endpoints. Without endpoints, you can't use this argument. Okay, so just make sure you answer the question. Always go back and make sure you answer the question. And the question is, what are the dimensions? And don't say 2 this time.
That was her.
That was, no, it wasn't Myra. That's not the way I'm remembering it. The dimensions are?
Video.
I never watch these videos. I don't want to find out how big my butt really is. Okay, so final dimensions, what's the length?
Length will be 16.
The length is, what we found was W, so W is 8. The length is 32 minus 2 times 8, which is 16. And give me some units, and yes, Polymon was right. Yards. Everybody feeling good about this? All right, between now and let's call it 9:15, your goal is to tackle the next couple of problems. I'm going to keep changing them up on you a little bit. This is a great model to look at. For the friends at North Central and East End, I'm just going to randomly pick some papers to put up here in a few minutes. Maybe what you guys want to do is pause the video, work for a little bit on the problems on page 26, see what you can do. We'll play and we'll talk in a little bit.
It doesn't say that, because in the previous problem it said not to use the slides, but it doesn't say that.
It says, let's solve this problem again. This time the guy is going to use 2 sheets of paper. They still have the same 32, right? What?
What are you saying? This would be 18? Yeah.
Probably not.
I'll get there.
I'm glad your instincts are developing.
Slowly but surely.
You're like, this sounds like the kind of thing that's going to get me in trouble.
So we still have 32.
Oh, and then it says, yeah, before.
Just dividing the extra. He doesn't want that.
Okay, so what do you think the answer is?
Just adding 4 both of these, 20 and 12.
Okay, I appreciate you're going to work it out.
What was that? Supposed to be 0.
No, walk it out. Walk it
He
out.
said 14.
Let's solve this problem again. This time the garden club is going to use 2 buildings to form the sides of the garden. How much greater is there in the garden?
It would just be like if you were just beating it quick, you just subtract the 4 and 4 and add it to these.
And so what would you tell me the final dimensions are?
The length would be, and then the width would be 12 yards.
So 20 and 12. Okay, so first of all, let's make sure that that meets the constraint. Adds up to 32, and is that going to give you the best area? You think so, which is fine. Like, trust the instincts. Now let's prove that you're wrong.
The wrong?
It's
Yeah.
wrong already.
Oh.
I already confirmed that one of them is wrong.
Yeah.
Okay, yes.
Alright, how are friends?
We're probably
Did
looking
he
at just study it first.
Okay. Alright, so what's the constraint
The width is not.
or the constraint equation?
No.
The width
Length
is
plus width equals 32, right? We took away one of the sides. What are we trying to optimize?
Remember what we did last time? We solved for L, right?
The area length times width. And honestly, like a lot of this process, you're gonna do it again. You're like, you got it. Now let's see what happens.
The area is length.
Generally speaking, I think calculus students struggle in identifying the constraint to the optimization. And like once they get here, you're like, I know what to do. I'm gonna follow the process.
It'll be 16.
Friends back here, how are we doing?
Oh, right, you're right.
It'll be 16.
But I'm not just gonna guess that.
She's right.
It's 15. Is it 16?
what
We're
variable
talking
are
about
you
a different
doing
thing.
Oh, I was like, did you say 15? 15 is 32.
We're talking about
Okay, you're missing two.
Okay.
Hey Grandma, they're sitting right across the table from you.
Sorry.
Yeah.
Well, because they were getting mad at me because they thought it was.
They're
Okay.
just jealous.
Yeah.
Focus. Okay, so Stephen is saying that the length is between 0 and 32. How do we feel about that being our domain?
I never watched the movie.
They don't believe you? What do you think the domain restriction is? 0 and 32, so you do agree with that. You're just not willing to admit it out loud. So the two of you agree that it's 0 and 32. What are the two friends over here think?
Oh, I thought you said how you spell 16. So I was like, why would you just spell? But I was like, why would you?
I agree.
You forgot.
Then you have no.
No, she got it.
Bye.
But yeah.
You got them both?
Yeah. It's 16 is 16. Okay, never mind, you know.
Well, that's great.
Okay.
Oh, like,
Wait,
like
is
this? You can't find this? Like how she got that?
Where are we at?
Oh. When you do it, you just have to
No, but I want to remind you
look
guys,
at this equation.
even if this is the right answer, you don't have enough
Look at
variables
this
to
equation
see that
and
that's
just
the
put
right
it in terms of.
Oh, yeah, that's the object, you do the difference.
Yeah.
Yeah.
Because now you're taking it
I
over.
heard you did.
Good.
Huh, yeah,
Good. And so you're going to do a number line test.
It is 0.
I'm just going to put this up there.
Don't you talk.
There's 2.
This is just open. Don't fix loose. Fix it again. Don't fix loose.
No, I know. I know how it works.
16 squared. That's 256.
Okay, well.
Don't you touch it.
Okay.
You know you like it.
Absolute
How much good is the
max
Wait.
W equals 2. 16. What? What?
Where's your area?
What do you mean?
I was like, that's not right.
I mean, either way, it wouldn't matter. It'd still be smaller than 256.
All right, so just want to jump in real quick here for the folks that are in the room and for the folks on the other side. We've got some beautiful work here. We've got length, we've got width, we've got our constraint that says 32 equals the length plus the width. The area is length times width. Of course, if I want to take a derivative, I'm going to go back up to this initial equation and solve for L or for W, doesn't really matter. L equals 32 minus W, and you plug it in, 32W minus W squared, take a derivative, set it equal to 0, solve, W equals 16. Not the best answer yet. It is your candidate. Don't stop here, you have to keep going. So once you've done that, if that's your candidate, maybe you want to identify your domain restriction. Your domain restriction is going to be from 0 to 32. Love it. So we've got a continuous function, right? A is a continuous function. We've got a closed interval. Last time we did the number line argument. Did anybody just plug everything in and
Nope,
like
no
that?
bad hombres here.
None of those friends here. So if
Wait.
the area is 32w minus w squared, my question is, did anybody just say, let me plug in all these numbers and see what happens?
Yeah.
When you have endpoints, this is a great way to go about doing it. Strongly recommended. Because the only place you could have an absolute max for a continuous function on a closed interval is at the candidate or at the endpoints. So do it if you can. What's the area if the width is 0?
0.
0, and the area if the width is 16.
256.
What do we get?
256.
Wait,
256, I think is right. And the area if
Can't be
it's 32
negative.
0.
has to be 0. So your maximum area is 256 square yards. So your length is 16 yards, and your width 16 yards. What did we just make? We made a square, which hopefully makes sense that in a situation like this, if I want to come up with a rectangle of the greatest area and I just have one length and I just have one width, a square is going to be the best way to go. Everybody good?
Are you saying that we can just say that?
Well, it doesn't always work.
Okay.
Like the last
So the-
problem when we had one length and two widths, we didn't build a square as the optimal
Well,
answer.
I'm talking about one length and one width.
One length and one width, a square is going to be an optimal solution. Okay? All right, I'm really interested in your setup on the next one. I'm not going to give you enough time to finish the whole thing. See what you can do. Giselle, I gave yours back, right? Okay. Steven,
Did you subtract?
did I subtract?
You didn't finish the problem?
Did I finish the problem?
Asking how much weight it is.
It's, yes, this new garden has an area, it's 128 square yards greater.
They have chickens now.
100 once the grocery What was that area?
Oh, it's 8 by 16, so that's 128.
Minus
Would be 128.
Oh.
Yeah, what is like that?
I have a chicken.
Maybe
16 times 16.
Wait, time out. This is like,
it's 120.
It's the same perimeter?
6 times 6 is 30.
Wait, is it?
Son, this is why we don't work.
yes, no.
Okay, we
Well, you
don't do that stuff.
Oh, yeah, because you have to treat them separately, don't you?
But they're equal, so you could.
Yeah.
All separate but equal.
Don't say that.
Don't say that.
Don't say
You just did!
No, I didn't.
You're like, the plants and the chickens are separate, and then Celeste is like, but they're equal.
Well, plants and chickens are.
Plants and chickens are not equal.
They are the one. We eat both.
You eat both, okay.
You don't. You eat plants?
Shut up!
You're vegetables. You're a herbivore? Oh.
Shut up, or the T-Rex is coming over. Just because
Ah,
I
you got
submitted
short
your letter of
arms.
recommendation.
You got short arms.
I mean, I'll be a raptor.
Damn, you got
With my one long toenail. Alright. Only gonna worry about the setup here. Gardening clubs decided they also want to raise chickens in this area. To keep the chickens from eating plants, they're gonna use part of the fence and divide the garden into two sections of equal area. The extra piece of fencing is parallel to the building and must connect the two parallel sides. Okay? So I'm putting fencing here, 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 and there. So length,
No, you
width,
don't.
and width. So my constraint should be 32 equals 2L plus W. My area is length times W, right? So if I solve this equation, I think you're going to get 2L equals 32 minus 2W. L equals 16 minus W. So your area is 16 minus W times W. Is everybody okay? Okay. All right, so that means that my area is 16W minus W squared. A prime is 16 minus 2W. I set that equal to 0. W is equal to 8. I've got a candidate. All right, if that's my candidate, I'm curious, do I have domain restrictions in this case? Pretty sure I have a lower limit of 0 for my width, my upper limit for the width.
That could be. No, it would be 8.
What's the upper limit for the width?
I think it is 8 because it's 2.
But it's actually not going to be 8 as your upper limit.
16.
Because you could you do 10 yards and 10 yards? Right, you could do 10 yards, that's 20 yards leaving, 12 yards for the two pieces here, so you go 6 and 6. So 8 isn't the upper limit for the width. The upper limit for the width is 16, right? You're going to the extreme case of spend all 32 yards on the sides, be the dumbest farmer ever, okay, and no length, and then put plants and chickens along this little line of fencing that has no area. All right. I'm pretty confident that all the friends in the room can finish it off from here. Are we good? All right, so now it's time for the push.
Oh, there's
So if you want to take a minute and finish it off, that's fine.
Is it semi-semi?
Doesn't matter. You get hit by a semi-truck, does it feel the same as a semi-truck?
No. Nothing was the same.
Oh, remember the part I said I missed you guys yesterday?
No.
That might be a lie.
Well, whatever.
I said I missed you all yesterday. But that was before you got here.
Oh wait, you can just find the area of the circle. Divided by the area. Oh wait, we don't have the. Oh wait, this is 4.
We'll solve it after the problem.
Wait, we have it.
Alright. Aaron, can I get you back here to drive one? If that's no, you can just be no.
David wants to drive.
David wants to drive. David wants to drive. Alright. Alright, friends, this is the push. This is how we're going to spend the next 2 days. For all of you who are like, why was everybody crying last year with optimization? These problems haven't been too hard. Good. You've had a pleasant 25-minute experience in the world of optimization. Now it's time to go for the real stuff. All right, Stephen, can you read the introduction to the problem?
A rectangle is bounded by the x-axis and a semicircle y equals the square root of 16 minus x squared. What length and width should the rectangle have so that its area is a maximum?
Okay, so the situation is we've got a semicircle, we've got a rectangle inscribed. Inscribed just means
Inside.
inside and touching. The circle is like creating a boundary. Okay? My goal is to figure out what is the area. What's the rectangle that has the greatest area, right? All right, so I want to see what you can do. Take a minute, see what you can do with coming up with constraint, optimization, and any domain restrictions. See what you can do. We'll talk in a little bit. And Stephen, with the camera where it is, are they going to be able to see if I'm writing over here?
Now they are.
Okay, good. And they can still see this? Yes. Perfect. So I'm looking for constraint, I'm looking for optimization, and I'm looking for any domain restrictions that you might have.
Wait,
I
wait,
square.
No, yeah, it's not just two.
Wait,
Because
four.
if it's 4 is
I think you need to put this in.
Area.
are we talking about
Circumference equals.
I'm talking about
Yeah, I know. Like,
4.
Oh, wait,
Well, yeah, 4 negatives, like so it'd be 0 or something.
That was dumb. That was a dumb start.
So,
It gives you the equation.
Yeah.
That's what you just said.
That's what's out.
not equal.
Can't you
It
allow
would
it?
be one.
No.
I'm sorry.
How do you have a negative
It
area?
wouldn't be a rectangle.
That's what I was thinking.
Wait, did you mean?
Yeah, no. It's go.
No, 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 no. It's negative 4.
You get
It's
the
negative 4. Yeah,
Yeah.
it's negative 4. That's what it was trying to say. Is that what you're trying to say?
Yeah, you said it's
Thing stops. Yeah, no, it shows it right here. It's negative 5 right here. Stops at negative 4. It means that 5.
All right, friends, let's pull everybody together and let's use the magic that is Geometers Sketchpad. All right, David. Okay, so let's make sure that we get the situation going on here. We've got the circle, we've got the rectangle. What I want to do, David, is click Animate X. Right, what I love about Geometers Sketchpad is you can see it, right? You can see what's going on. You can see all these different cases. And like in the very beginning over here, we're starting off with a really tall rectangle that's not very wide, and then it winds up getting really wide but not very tall. There's a whole lot of different rectangles that you can consider. If you're looking up here where the numbers are running, you've got the X value, you've got the corresponding height value. David, whenever you want to, just click Animate again so that it pauses. There you go. So if X is 2.982, according to Geometers Sketchpad, the height is 2.666. And the area is 15.900. I know, I saw the 2.666 and I was like, oh no! Everybody okay? Is that the best area that we can come up with? Let's click Animate again and see if David can get us closer to the best area.
He goes back to it.
15.934, better. Is that the best?
Never.
Let's see if you can do a little bit better. $15.678?
No.
Maybe not.
Keep going.
See what you can do. 15.891. Okay.
Pretty close.
Brett, we're getting pretty close. What are your instincts telling you, Aaron? What do you think the best area is going to be?
16.
Right, we're seeing 16 maybe. Are we getting new desks?
I think so.
Yes, please bring those beautiful desks in here. And that Bobo desk back there that doesn't match, let's get that out of here. Let's get that Bobo desk out. If it doesn't match, I don't want it. Go.
Why are you running? You're driving. Who's driving?
No one's driving the car! Yeah, that's appropriate, Aaron. All right, good.
Dang, someone should have turned the camera.
All right. All the friends are okay. We have chaos going on North Central and East End. If it really continues to go bad, I might just go teach there. All right, everybody okay? We've got a rectangle, we've got an inscribed circle, we got all the things going on. We have some evidence that there's going to be a maximum. That's fine, that's fine, that's fine. All right, Aaron, back to you. Click on what's the circle's equation. And it's hard to see it over here, but it should be y equals the square root of 16 minus x squared, which I gave you in the problem. Okay, what's the top semicircle's equation? Click show. Right, it's just the positive version. We're not going to consider the positive and the negative. What's the x coordinate for point C? Click show. All right, the x coordinate is going to be x, dirt. The y coordinate is going to be the square root of r squared minus x squared.
Wait, that's...
So for any point on this circle, I go over x, and then I'm going to go up to the y coordinate, which is the square root of 16 minus x squared. And all the friends are okay? What's the optimization equation? What is it that we're trying to optimize?
The rectangle. Wait.
Area.
We're trying to optimize the area, right? We get 4, we get 8, we get 12, 16, 20, 24. I think we're supposed to have a total of 28 desks. And because I think that's supposed to go, and I think those folding chairs are supposed to go. Are you doing okay? I know you had no idea what you get yourself signed up for. So if you want to get rid of that, that would be fabulous. All right, we're trying to optimize the area. The question is, what's the area for the rectangle?
Length times width.
Oh.
Well, yeah.
Length times width. Now what I saw a lot of folks had was x times the square root of 16 minus x squared. How many guys had that on your paper? Nobody had that on their paper?
No.
What is the actual equation?
X squared.
X squared?
No. 2x squared.
Look at the rectangle. How long is it?
Oh.
How long is this rectangle? It's not x.
Wait.
Right, x is from the origin out here. I need this side as well. So the area is going to be 2x times the square root of 16 minus x squared. Okay, so that's what you're trying to optimize the domain. What are my values? What are my possible values for x? I saw a lot of folks that were saying we're going to go from -4 all the way out to +4. But you're using x to represent the distance from the origin.
You gotta stop that.
So, what do we have for our domain restrictions here?
-4 and 4.
No.
No, you just said no.
0
Not -4 and 4,
You already.
from 0
to 4.
to 4. Because if you look at the way that things are labeled here, Polymon, we're going from the origin out to this point. So it's going to be from 0 to 4. All right. Now, here's the thing. I am pretty confident you guys know the calculus that we're about to engage in, right? Have a conversation with somebody near you. What are you going to do? What's the calculus you're going to do? David, I'm coming over here. What's the calculus you're going to do? Your area is 2x times the square root of 16 minus.
What are you going to do?
Calculus is about to happen.
Right.
You're going to take derivative.
F of X. F of X.
You're going to find the derivative. You're going to set this equal to 0 to find your candidates, right? All right. So in my conversation with David in the back, David and I were talking about we're going to take the derivative. We're going to set this equal to 0 to find the candidate. Once we know the candidate, we're going to go back and plug into the area equation, and we're also going to plug in the endpoints because, my goodness, we have endpoints. Everybody okay?
Yeah.
Now, here's what I want to do. I want to finish using Geometers Sketchpad. So, if you can show me, all right, what's the height? Express the area. If you can click show. All right, and just click outside of there so it's not highlighted. 2x times square root of 16 minus x squared. We've had that conversation. Maximize the area. We're not going to quite do that. There should be somewhere over here. Is there a button that says like show the graph of a of x?
Show the graph of a of x.
Top right.
Okay, no, because you're in. I get you.
I gotta jump on this.
I swear I saw it this morning.
Oh, what?
Max X. I swear I saw it this morning. Ah, there it is. Sorry. Sorry. All right, everybody focus. Back to me. Sorry. That's what happens when you practice this at 4:30 in the morning. Okay. The graph on the side is your area function as a function of x?
Yes.
All right. David, animate x again. Right, x is increasing, the area is changing. I've got the graph over here, and hopefully looking at the graph, you guys know for sure there has to be a maximum.
Yep.
Right, the benefit is I can see the graph. I know where the, dang, somebody's getting good. Now, is this the absolute max? Is this the absolute best?
Looks like it.
It looks close. I may not know for sure, So we could look at the graph of a of x, but sometimes I'm not going to give you the graph of a of x. Show me x a prime of x graph. Right? So now we're looking at the graph of the derivative. Where, if I had only the derivative graph, where am I going to look?
I look where it equals 0.
You're going to look where the derivative, not just where it's equal to 0,
Positive to negative.
but where there's a change from positive to negative. I hope you guys are convinced by looking at the graph of a of x that this relative max is actually an absolute max. Who can convince me based on the graph of the derivative? 2 people, 3 people, 4 people, 5? Carmen, convince me based on the graph of the derivative, why is this relative max an absolute max?
Because what is it? Time?
What's happening in the derivative?
The derivative is changing from positive. And
The derivative's changing from positive to negative. That makes it a relative max. That's not what gets me to an absolute max.
But because it's the only change on the derivative.
Because this is the only place where the derivative graph changes, it has to be an absolute max. Is everyone convinced? Good. So now it's just the calculus. Yes, sir?
You want me more this?
Do I want 3 more desks would be great, and if we can get this thing out of here, that would be even better. All right, I'm gonna leave that to you. You look like you're big and strong, and I got some calculus to do. All right. All right. So all this good stuff over here was like the graphical evidence. We're gonna spend the last bit of time on the calculus. So go take a derivative. You're waiting for me to do the derivative work. A of x is 2x times the square root of 16 minus x squared. I need the derivative. How are we going to take the derivative of something ugly like that? Product rule. So product rule says derivative of the first, which is 2. Leave the second one alone. Oh, I love it. Derivative of the first times the second plus the first. Now I need the derivative of the square root of 16 minus x squared.
1 over 2.
Right, derivative of square root of stuff, 1 over 2 square roots of stuff times negative 2x. I would say this is probably worth 2 points. In terms of like finding the derivative, I'd probably give you 2 points for that. So now, you've got to set it equal to 0, and you got to solve it, and Aaron, as bright and as gifted and talented as you are, I don't think you're just going to look at this and be like, the answer is blah. So what we need is some algebra cleverness.
It's 15.96.
Oh, okay. I'm going to leave this guy here. 2x times all this stuff times negative 2x. 2x times negative 2x was at negative 4x squared? Negative 4x squared. And I've got a 2 in the denominator. Life is good for me. Negative 2x squared over square root of 16 minus x squared. Now here's the thing. You've got to figure out where that's equal to 0. Yeah, you keep going. All right, so finish it off. We need some algebra cleverness here. Steven, what you got?
You could add one side to the other side with a negative side.
All right, you could move this fraction over to the other side. So you've got 2 times square root of stuff equals 2x squared over square root of stuff. Why would that be better?
Oh, I mean, because then you could just use multiplication and division.
All right, so what I heard Steven say is, what if we moved the fraction to the other side?
Wait. Before you do that, you actually just make the denominators the same and cancel.
Oh, okay. So we've got a lot of algebra stuff we could do. So one thing is you could say, let me move this fraction to the other side. This guy equals the fraction, and try solving it from there. Maybe what you decide to do is put this over 1 and cross multiply. Legal. This is legal. Another option, join my gang, we talked about this the other day.
Fraction killers.
Fraction killers.
Oh my god.
To be a fraction killer, all you need to do is look at this equation over here and tell me what's the common denominator. and the common denominator, there's only one, must be square root of 16 minus x squared. Multiply everything through by the common denominator. Square root of 16 minus x squared times 2 square roots of 16 minus x squared.
2 times 2.
Right, square root of stuff times 2 square roots of stuff is 2 times 16 minus x squared. Square root of 16 minus x squared times this fraction over here, guess what?
2x squared.
Is just negative 2x squared. Being a fraction killer is a good thing. Okay, distribute, so now you've got 32 minus 2x squared minus 2x squared is equal to 0. Combine like terms. 32 is equal to 4x squared. What is that, 8? So x is plus or minus the square root of 8. Which is actually not 4.
Oh my god.
So 2 candidates.
1.
1.
David, why 1?
Because our domain is from 0 to 4.
The domain is from 0 to 4, so your candidate, the only one true candidate, is x equals the square root of 8. And the square root of 8, last time I checked, is somewhere conveniently located between 2 and 3, closer to 3. Look at the graph. A prime, the root is between 2 and 3, closer to 3. Specifically, if I went and I found what the square root of 8 is on my calculator, it's like 2.828 something, something, something.
427.
427. David's estimate right now is 2.729. Things are good. Okay? Now, here's the nice thing. Because this is your one and only candidate, you can go back to the area function and say, let me evaluate the area function at my endpoints in the candidate. Area if x is 0, 2 times 0 times stuff, why do I even bother? 0. If I go to the other extreme, 4, 2 times 4 is 8, times square root of all this stuff over here is 0. That seems to match the graph. Now I need to plug in the square root of 8. 2 times the square root of 8. Now this part over here, we're going to be careful. Square root of 8, square it. 8. 16 minus 8. 8. So I've got 2 times the square root of 8 times the square root of 8. Square root of 8 times square root of 8 is
16.
square root of 64, which is 8. And you're going to get 16. So that is your best area. And if somebody could read the question, what actually was the question we were after here?
What are the dimensions of the rectangle?
What are the dimensions of the rectangle? What are the dimensions? How long?
0, 4.
How long is the rectangle? We figured out the best solution is when x is equal to the square root of 8. So how long is the area rectangle with the best area? 2 square roots of 8. How tall is it? It's going to be, plug that in, I think you're going to get the square root of 8. Is everybody mostly okay?
Oh, I knew it.
All right, so tonight's homework is assignment number 56, questions 1, 3, 4, and 5. And I think I need to go find that young man who brought in the desks because we're supposed to actually, we were supposed to gain desks, not lose desks. I think the Bobo desks are coming back. But this has got to be, this is good. This is progress.
I got it as soon as possible.
Questions?
1, 3, 4, and 5 on assignment 56.